Hey guys, we're going to do notes now over geometric sequences. So last time we talked about the common difference when we have an arithmetic sequence. And then today we're going to talk about common ratio with a geometric sequence. So basically what I hope you remember from the last set of notes was that when you have an arithmetic sequence, you're adding the same number every time to get the next number. For a geometric sequence, you're going to multiply by the same number every time to get each term in the sequence. So you have a common ratio with a geometric sequence and a common difference with the arithmetic sequence. We also learned last time that arithmetic sequences are linear. And so the equations kind of take the form of y equals mx plus b. Whereas a geometric sequence, those are going to be exponential. And so it takes the form of like y equals a times b to the x power. So when you have a geometric sequence, you'll have your list of terms. I'm going to rewrite them because it kind of got cut off over here. So a1, a2, A3, A4, etc. So the way you're going to get the R value, or what you're multiplying by each time, is you can take any consecutive set of numbers, like the A2 term and the A1 term, and divide them. So do A2 divided by A1. Or you can do A3 divided by A2. Or you can do A4 divided by A3. So the fourth term divided by the third term. Just kind of depends on which ones are easier to look at or to evaluate it from. So some examples of geometric sequences. If we write the first four terms of a geometric sequence where we've given you this explicit form, this number right here that's being raised to the exponent, that's our R value, which we kind of tell you that right here when we say the common ratio is 2, but just so you know, the number that's been raised to an exponent, that's your R value. So to get the first term, you're going to do 2 raised to the first power. You just replace n with 1, so you get 2. If we're going to write the second term, we're going to do 2 squared, which is 4. The third term will be 2 cubed, which is 8. And then the fourth term will be 2 to the fourth, which is 16. So those first four terms are 2, 4, 8, and 16. And hopefully you can see that the difference between those two is you can get from one to the next by multiplying by 2 each time, which is what makes it geometric. Okay, on the next example, what's special about this one is the fact that right here we've got this negative. That's pretty important. The fact that the negative is being raised to an exponent. What I want you to think about when we have that situation is the signs are going to alternate. I'm going to write here alternating signs. Because what you're doing is you're doing a negative 1/3. Well, let me do it this way, sorry. To get the first term, you're going to do a negative 1/3 raised to the first power. So when you raise a negative value to an odd power, it will stay negative. Whereas when you do a negative power to an negative number to an even power, it's going to become positive. So negative 1/3 times a negative 1/3 is 1/9. When I do a cubed, I'll do a negative 1/3 to the third power, which is a negative 1/27. And then a to the fourth would be a negative 1/3 to the fourth power, so a positive 1/81. So your four terms would be 1/3, a negative 1/3, 1/9, a negative 1/27, and a positive 1/81. So hopefully you notice here that the sign has changed every other one. So anytime you see a sequence where that's happening, you know that you probably have a negative value inside getting raised to a power to make that happen. Okay, so the way we're going to get the nth term, or the explicit formula, is using this formula right here. So kind of like what we talked about with the arithmetic sequences. I want you to notice that this n right here matches that n right there. And this 1 will match this 1 right here. So basically, you know, if you wanted in your calculator, you can always do exponential regression to figure out the sequence or the formula for the sequence. When you do it in your calculator is going to do a sub n, but they choose to put the a sub 0 for that number in front of the common ratio. And then your common ratio will be next, and it's going to be raised to the n minus 0, which normally we don't write the minus 0, but that's where those numbers come from. Those would give you the exact same sequence. It's just, you know, you're using a 0 instead of a 1, but you have to make sure that this matches this right here. So sometimes we're going to have problems where we have some just random terms that are given to us, and we've got to write the formula for it. So let's say I give you the 54th term and the, 17th term. So then you're going to write it like this. You'll have a sub 54 equals a sub 17 times r, and then these numbers will be 54 minus 17. So those are just the term numbers. You're not actually putting the value of them. You're just putting this little number here and this little number here. That's what's going to be the exponent for that. All right, so this first example here, or example 2, it says to write the first 5 terms, where the first term, a1 equals 3, and our common ratio is 4. So probably the easiest way to do this is just start with your first term, multiply that by 4, because that's my common ratio, to get 12. Multiply that by 4 to get 48. Multiply that by 4 to get 192. And then multiply that by 4 to get 768. So that is our first 5 terms of this geometric sequence. Okay, on this next one, we were asked to find the 15th term when the first term is 20 and our common ratio is 1.05, or 1 500ths. So we're going to use our formula. The best way to memorize this formula is to write it down 1,000 times. So we're going to get the 15th term by plugging in the first term, and then our r value will be raised to the 15 minus 1, because again, we're using those numbers up here for our exponent. So to get the 15th term, we'll take 20, because that's our first term, times our r value, which is 1 500ths, raised to the 14th power. So you're just going to type that in your calculator, and you get 39.598. I'm just going to truncate it, so just stop right there on the third number after the decimal. On the next example, it's asking us to find the formula. So we're going to be writing the explicit formula for the nth term. So, you write it in this format. A sub n equals a1 times r raised to the n minus 1. And then they want us to find the 9th term after that. So you're going to look at this sequence right here, and you're going to think about, what do I multiply each of these by to get the next term? And if you're not sure, just always do r equals 15 divided by 5, or I could do 45 divided by 15. Either way, you're going to get 3 for that r value. And then my first term is 5. Every time we give you a sequence, we start with the first term, so that'll be a1 right there. So I'm going to plug that in. So to get my formula for the nth term, I get a sub n equals 5 times 3 raised to the n minus 1. So this is my explicit formula. Now I can use that formula to find the 9th term. So a sub 9 is going to equal a sub 1 times r raised to the 9 minus 1. So a sub 9 equals 5 times 3 to the 8th power. So when I type that in, I get 32,805. Okay, on this next example, it's a little harder. They gave us the 4th term. It's 125. They gave us the 10th term. It's 125 over 64. And they've asked me to find the 14th term. So we're going to use our formula, which I'm going to write again so that it's easy to memorize. But instead of using this n and this 1, I'm going to use the 10th term and the 4th term, because that's the numbers or the ones they gave me. And then multiply that times r raised to the 10 minus 4. So plug in what they gave me. I have 125 over 64 equals 125. I'm trying to figure out what r is, and then it's raised to the 6th power. All right, you're trying to now solve this for r. So you've got to undo the things that have happened to r. So the first thing that's happened is it's multiplying by 125. Remember, when you solve any equation, you have to undo your order of operations backwards. So there's parentheses, exponents, multiply and divide, add and subtract. And you always undo them backwards to solve. So undo adding and subtracting first, which there isn't any. Then undo any multiplying and dividing. So I've got to take care of this 125 first. I'm going to divide by 125 or multiply both sides by 1 over 125. That's the same thing as dividing by 125. So when you do that, it cancels over here, and it's going to cancel right here. So we are left with 1 over 64 equals r to the 6th power. Now you need to get r by itself still. So now you've got to take care of that exponent. And the way we unsixth something is by taking the 6th root. So we'll do that to both sides. And what you should be thinking about is, what number do you multiply by itself 6 times to get 1 over 64? You can also in your calculator type 1 over 64 raised to the 1/6 power. That's the same thing as taking the 6th root. And you should get 1/2 equals r. So now I know my r value, and I can use that to find the 14th term. So I don't know where I'm going to write this, but let's see. To find the 14th term, we're going to take the first term, multiply that by that r value, which is 1/2. I'm sorry, I can't use the first term. I don't have it, so I'm going to do the 4th term. Sorry about that. So then my exponent is going to be 14 minus 4. So our 4th term is 125 times 1/2 to the 10th power. So when I type that in, I'm going to make sure when I type it in that I use alpha y equals in my calculator to type in that 1/2 so that it looks like a fraction, and it's going to give me an answer that's a fraction. So I get 125 over 1024. So that is the 14th term for this sequence. And I'm sorry, I kind of got into this other area right there. So your quiz is going to ask you to give all answers as fractions and not decimals. So you can, if you got a decimal answer, you can always hit math or enter on your calculator to get the fraction. All right, the next one is a very similar problem. So this time they give us the 2nd term is a negative 18. They give us the 5th term is 2/3. And they want us to find the 6th term. So I'm going to use my formula. I'm going to say a sub n. I'm going to write it again so I have it memorized. So I'm going to use the 5th term and the 2nd term, because that's the one they gave me. So and then multiply that by r raised to now the 5 minus 2. So you're going to replace a sub 5 with 2/3 and then a sub 2 with negative 18, and multiply that by r raised to the 3rd power. And I'm going to multiply both sides by 1 over 18, negative 1 over 18. That way this cancels over here. Over here, 2 goes into itself 1 time, and it goes into 18 9 times. So that becomes a negative 1 over 27 equals r cubed. And then you're going to take the cube root of that. So cube root of both sides. And when you do that, you end up with r equals a negative 1/3. So that's our r value. Now you can plug it back into the formula if you want to, but you can also notice that right here, we've been given the 5th term. We just need one more term after that because they're asking me for the 6th term. So I'm going to kind of be lazy. To get the 6th term, all I have to do is take the 5th term. Oops, sorry. I'm going to take that 5th term and multiply it by my common ratio, and it gives me a -2/9. So that's what the 6th term would be. And that's probably the lazy way to do it. So let me actually show my work. So another way to do it is to get the 6th term. We're going to take the 5th term. We're going to multiply it by our r value, which is a -1/3. And then you're going to raise it to the 6 minus 5. That all kind of ran together, didn't it? Sorry. Let me make that better. Sorry. So to get the 6th term, we'll take the 5th term, we'll multiply it by a -1/3 raised to the 6 minus 5. Okay, so my 6th term will be the 5th term, which is 2/3 times a -1/3 raised to the 1st power. So it's basically what we just wrote a while ago, which gives me a -2/9. And that's my answer. All right. Okay, now we're going to do the sum of a finite geometric sequence. So there's a huge difference between this one and the one down below where we're doing infinite. And mainly what you should notice is that whenever you're doing a finite one, it's going to end at some point. So it has some end value up here on top, a number that'll be where it ends. On infinite, that number on top will be infinity. So in this case, you have this that you can type into your calculator by typing either math 0. That's probably the easiest way to do it. Just hit math 0 and then it brings up the summation symbol for you. Or you can have this formula memorized. And I'll show you both ways. Okay, so if they give it to you like this, it's probably easiest just to type it in your calculator. You'll do math 0. And then you're going to put in on the bottom, I usually use x. I mean, if I'm typing it in my calculator after I hit math 0, I'll do x equals 1 and then 12 on top. So but what that means is you've got 12 terms, the first 12 terms that you're adding together to see what their sum is. And this is the explicit formula that gives you each of those terms. Okay, so when you type that in your calculator, you get 1.714. And that would be your answer for that one. On the next type of example, oh, I'm sorry, I meant to explain it the other way too. So the other way, the other formula, to get the sum of the first 12 terms, we will take the first term and we'll multiply it by 1 minus the common ratio raised to the n power over 1 minus just the common ratio. So my first term comes from whatever number they have here on the bottom, the n equals 1. You're going to plug that in for the n up here in your exponent. So my first term will be 4 times 0.3 raised to the first power, which is 1.2. So it'll be 1.2, and then 1 minus the number that is your r value will always be the number right here that's raised to the n power. So you're going to do 1 minus 0.3 to the n power, which in this case is 12, all over 1 minus 0.3. And when you type that into your calculator, you should still get 1.714. Okay, on this next example, or next set of type of problems, we have an infinite geometric sequence, or another way to name it, we call it a geometric series. So what I want you to think about is different types of sequences, like that are geometric. So like, let's say we have the sequence 3, 6, 12, 24, etc. And then we have the sequence, let's say 32, 16, 8, 4, etc. So the one on top, as you go down the sequence, you should see they're getting bigger, so they're increasing. And your R value for that sequence would be R equals 2. On this one, the numbers are getting smaller. And if you think about what do you multiply each time to get the next value, your value would be R equals 1/2. So if you think about doing a sum, because we're adding these numbers up, and you're going to infinity this time because it's infinite, and you can see that right here, that number right there on top is infinity. So as you start, adding all of these numbers that are going to infinity up, they're just getting bigger and bigger and bigger. And so eventually they're just going to go to infinity. So that happens whenever your R value right here is bigger than 1, or at least the absolute value of it. So when the absolute value of your R is bigger than 1, your result will be infinity. Well, if you have an R value that's when the absolute value is less than 1, when that happens, you're going to actually approach an actual number. And so that's when you're able to use this formula right here. Otherwise, it's going to infinity, and you should give that answer if it's bigger than 1. But if it's less than 1, then you can use this formula. So you can't type infinity on your calculator, so you really can't use this formula in your calculator unless you make that top number a really large number, but then it kind of makes your calculator time out. So this formula you really need to have memorized. In this case, on our example down here, we've got an R value that's less than 1, so we need to use the formula. So we'll say S equals, my formula says A1 over 1 minus R. So your first term has to be using whatever number right here you have for n, you have to plug that in for n right there. So it'll be 4 times 0.6 to the 0 power, which happens to be 4 times 1, or just 4. So my A1 in this formula will be 4. And then it'll be 1 minus, again, that 0.6 is my R value, so we'll be dividing it by 1 minus 0.6, or 1 minus 6/10. So when you type that in your calculator, you're going to get 10. Or you're doing 1 divided by 0.4, which is the same thing as dividing 4 divided by 4/10, which is the same thing as saying 4 times 10 over 4, which ends up being 10 if you were doing it in your head. So as I said, if your R value is less than 1, it should approach some number, in which in this case it's 10. On this next one, I want you to think about the fact that if you actually did add all these up as they keep going to infinity, it would add up to look like this. Because we're just adding another 0.3, then 0.03, then 0.003. So this is the same thing as 3 with 3 repeating there. So I want to show you how it works with the formula though. My R value, if I'm not sure, I can do the 0.3 divided by 3 is just 0.1. And then you're going to use your formula. So S equals my first term, which is 3, over 1 minus 0.1. And so when you type that in your calculator, or, if you think about it, it would be the same thing as 3 over, when you do 1 minus 0.1, you get 0.9, or 3 divided by 9/10, which is the same thing as 3 times 10 over 9, which simplifies to be 10/3, which happens to be the same thing as this right here. All right, I want to do one more example. Let's say I had this sequence. Let me change pen colors. If I had an example where we had a sequence or a summation where we said this, and we have n equals 0, and this is infinity on top, and that's pretty important that that's infinity on top. And I did something like, 5 times 15 halves raised to the n power. So if you get a problem like this, you should automatically, because of this infinity on top, the first thing you should be thinking about is, what is this R value? That R value is bigger than 1. It's written as a fraction, but that fraction still is a number bigger than 1. So this is automatically going to go to infinity. As you add those numbers up, they're just going to keep getting bigger and bigger, and it's just going to go to infinity. All right, that's it. Thanks, y'all.